Hey, thanks everybody. Thanks everyone online and everyone that's here for taking the time out to hear from all these great partners that are here today as well. Just before I get into it, I guess my name is Andy Roberts. I'm an architect in our technology center in Burlington, Massachusetts, focused on data platform and AI. I've been at Microsoft for about 24 years. So I spent about 12 years in our consulting services, 8 years as what we call now a solution architect. The role I had doesn't exist anymore. And about three years here in the technology center. And we work with customers from all size and scale, from smaller startups to small, medium-sized accounts to larger enterprises across industries. So we focus a lot in Boston in healthcare and manufacturing, financial services, but also retail. Some big retail customers here in Boston. And we do anywhere from envisioning. So I work with customers, helping them kind of decide what the next step is for them to take. Because I think of my job as helping you take the next step to the cloud, whether that's in our Dynamics cloud, Dynamics 365, Microsoft 365, or Azure. Really understand how to get you there. So we do envisioning sessions, strategy briefings, design sessions, and even rapid prototypes and hands-on sessions with you as well. So really kind of taking through the gamut of figuring out what you want to do to actually getting you there. So as I was looking, thinking through and hearing some of these customers or these partner presentations today, I actually learned a lot. And that's one of the things I love about these Angelbeat sessions is it's talking about a lot of technologies and a lot of different spaces that I actually don't touch every day. So when I think about dark trace, when we kicked off this morning, one of the things that kind of ties into this session I heard a few times throughout the day is how much they're leveraging AI, right? So leveraging AI models in your security system. And yet, I like the idea of really kind of assumed breach. So that's one of the things that we've been talking with security engineers and Microsoft 365 and Azure over the years, and how they pour through things. Really just thinking like, let's just assume someone's broken in, right? It's not like trying to prevent them. I mean, well, obviously we're trying to prevent them, but we still have to assume that they're here, right? And let's go find them. And I just love that mentality. And learning with what's going on. From Suse, first of all, I learned learned how to pronounce your name today. I've been pronouncing that long for 20 years. What I think is just amazing is the partnership that Microsoft has developed with the open source community over the years. I think Ron had mentioned it, that we're one of the largest contributors to open source. I never like to say the largest because who knows how those numbers change all the time. But when I joined Microsoft, was SQL 6.5, Windows 2000 was just launching. Windows 2000 launch, we actually had Linux protesters at that launch in Boston. My job was actually as a bouncer because our general manager was like, they can't go in and see these CIOs that are sitting here for this, at the time, simulcast event, because that's how we did things back then. I think I remember you now. So fast forward to 2014 and we joined like the Linux Foundation, right? I as part of my job, I'm dealing mostly with open source technologies, right? I still do a lot with SQL Server, but it's a lot with open source. And we're really talking about, meeting customers where they are, right? And we're gonna hear from Amazon after this. And we think through like all these partners that are here today, that on some view, and this is like almost true of every company that we work with, is a partner, but is also a competitor, but is also a customer, right? So it's become pretty confusing, right? But in Azure, we want you to run, we want Azure to be the best place to run software. We think the Microsoft software is really, really good, but if you want to run something that's not Microsoft software, we want Azure to be the best place to run it. If you're using AWS or Google, we want the Microsoft software to perform better there than any other software you might run there, right? And that's kind of our commitment. That's the way that we think about this really wide ecosystem. of trying to meet you where you are to be able to perform the business operations you need to perform. The Zerto, 100 zettabytes by 2025, or the I always look at those numbers and I always say it's like gigantobytes, like, just the numbers are so huge that I can't even fathom how much data that is. It's just amazing. I could go through all of them. Out systems, UiPath, Fivetran, just took something away that would end up tying into this this session that I was talking through today. But let's talk a little bit about AI at Microsoft, and what we're innovating on and how it affects what you're doing in your business and your everyday life. So, first of all, what is AI? This is a definition. It could be simply defined as the ability to automate or predict something. I think of we put these big ethereal terms on things, right? I think of AI as the ability to host a predictive model. So we think about machine learning, right? Machine learning is generating a predictive model. And a predictive model sounds really fancy, but it's really just a math function, right? F of X, Y, Z, A, B, C, D, E, this big, huge matrix of variables equals some number, some probability that something's going to happen or not. And we're using that result. We're going to host that inside of an application. It could be a bot. It could be a camera that's doing predictive analytics to see whether they think there's a security breach. It could be in your AI subsystem. It could be in your networking stack to determine anomalies, right? Or predict capacity, right? To see whether we need to expand something. And those predictions should be driving behavior, right? So the idea of predictive analytics and AI is, not to put too fine a point on it, to change the world, right? At least according to the data that we're ingesting. So if you think of the universe in set theory of all the numbers that are coming in, we're looking to change those inputs. So I want to change behavior by making a predictive model, by hosting it inside of an application. Once I change behavior, my data is going to change. I'll have to retrain that model, and we have this evolution of ML ops. So we might talk a little bit towards the end. So where are we seeing big steps in AI inside of Microsoft? We'll talk a little bit about our cognitive services to start with. And cognitive services, I think it's kind of a Microsoft term. I found out, I was talking to someone about this. They were an ML engineer for another company. That cognitive services, what are you talking about? So I think this is a Microsoft coined term around, really it's pre-built Microsoft models that you can build into your application. So we have models around computer vision, around language detection, around anomaly detection, speech translation, speech transcription, things of that nature, that you don't have to do any work aside from just deploy it into your Azure subscription. You get the endpoint, a security key, and 2 lines of Python code or C# code or Java code or whatever code you want to write. Call that model, get a prediction. And we can build entire applications and stacks on these models. And that really enables the kind of the idea of saying, hey, we want to make building AI into your systems more approachable. I mean, if you look at the barriers to adopting AI in enterprises, this is based on a study in 2018, so it's a little bit old, but still in modern terms. But still relevant, as I talk to my customers, on a daily basis, they don't understand how they want to use AI, but they know they need to use it. And they don't have the skills. They don't think they have the skills, right? So how can we get people started, jumpstart into the process of using AI, building AI into their applications, into their workflows, if I don't have a room full of data scientists, right? Because who has a room full of data scientists? I heard State Street on the call. They do. Fidelity, a lot of big financial services, some big pharma, have these people. But to be a world-class data scientist, you need to understand the business, the technology, the application that's going to host that technology, the data that's making up that, that model, how it's going to be used in the real world, how it's going to generate revenue. There's all these variables. It's tough to find these people, right? So can we offload some of that work from our customers and maybe build some of that supporting structure, and then also put some processes in place where that doesn't have to be one person. That's a team, right? That's a team of people that are building models and putting them into production and monitoring them, making sure that they're operating correctly. So we think about three areas of kind of empowerment in Microsoft, three areas that we're really working into. The first we'll talk about is meaningful innovation. So not just developing AI models for the sake of developing AI models, but we want it to help you do something that is useful to you. Not just winning a game of Go against a computer, or against a human, or a game of chess, right? Although we do have a great reinforcement learning video around beating Pac-Man with reinforcement learning, but I don't have that embedded today. And that's all to empower people to do their jobs better, right? We talked about process automation. One of the Amy Hood, our CFO, she was speaking one day, and one of her quotes that I can never remember exactly. I should try and find this keynote. But she said, I wanted to take all the manual processes out of our closing the books and stating our earnings. And so I reached out to my team and I said, we want to automate this. And so they went and they started automating stuff. But there were still all these manual processes because all the things that were automating were error prone, right? So they would automate something that would spit out an error that someone would have to go chase after. And they said, all right, stop. I don't want you to just automate everything. I want you to find out what all our processes are, improve them, and then automate that. And so with that, there was actually that started, people really thinking, how do we handle all these cases, of where things could go wrong, where things I could be kicking out to a person that I could actually make a decision on. Those decisions that we're making, a lot of times those are based on machine learning models, right? Is this, if you look at, if you do a search for modern finance, Microsoft Modern Finance, there's some good architectures around our process automation for closing the books and for cash flow analysis, and predictive analytics around anomalous transactions or things that would have been red flagged that had to go to a human, that we can now make decisions on with computers. And finally, responsible AI. So responsible AI is something that pretty much anyone that's been in the AI space has really had to think through in the past 4 or 5 years. It's not just a game anymore, putting predictive models out there. When you have potentially law enforcement using vision services to make decisions, if you have banks that are doing credit loans, loan risk analysis, default analysis, there are decisions that they're making, and we want to make sure that we're making them in a responsible way. So an example, like Ernst & Young, we have a good case study with them where through the use of a technology called Fair Learn inside of Azure ML, we were able to take their kind of, they worked with a bank to take the corpus of loan applications and what they were actually approving for loans for people. And they found like a wide disparity over a couple of demographic differentiators. But by going through this process, they found that they were able to take on the same amount of risk as a bank, but spread that risk out across across all demographics and kind of level the playing field there. So there were decisions that were being made that were automatically kind of just skewing the results one way, but just applying some processing and some statistical analysis, we were able to respread that same risk, give value out to a wider base of the population effectively. So an example of meaningful innovation. This is an example of kind of computer vision. I'm detecting all of these things in a factory floor, right? I might have moving belts might have people without the proper protective equipment, like hard hats. I might have a flammable or heat source. And now we start thinking about spatial characteristics, right? Am I moving close to that hot thing? You know, do I not have the hard hat on, but I've crossed the line that ends up being kind of a danger zone? And when we start thinking about, how we leverage the cloud for these technologies, a lot of times we're using the cloud processing for the really, really hard math, generating that mathematical function I told you about, generating the machine learning model. And so we'll bring a lot of data, a lot of video feeds, a lot of images into Azure, train models on that. But then the result of that will push onto the factory floor itself. So we run that, we call at the edge. Because if you're trying to prevent somebody from stepping underneath like a shipping container with a crane coming overhead, I don't have time to send that image up to the cloud, run a predictive model on it and send the result back and then alert somebody. I want to alert them right now, right? So those are some of the things that we're working on. And we actually have some really good success on workplace safety models with spatial analytics. And we'll hit on a couple of those. But in general, computer vision, doing more than just detecting, hey, is this a face? Is this someone with blonde hair or black hair? But really, what does this mean contextually in your business? And this is kind of the quote I was mentioned earlier. We're not just trying to have computers play games. We're trying to actually empower people to do things. Again, we're evolving capabilities across. I've talked about a few of these: object recognition. Ron's going to send out these slides so you can kind of get the lowdown on some of these, and we'll touch on a couple of them in the next few slides here. Image capturing is one example. Just kind of, again, thinking through evolution. We used to have look at this and we'd say, hey, this is a woman looking at the camera. Some of our competitive models are competitors to ours. We'll look at this and say, hey, there's two people. But what we want to evolve this to is a woman wearing a stethoscope around her neck, right? That's the subject. I found this one always interesting. Yellow sunset, hey, that's the dominant color. That makes sense. Others might have said a lamp or a tripod. That's kind of that shape. But really it's a satellite dish on a dirt road, right? So, this is the type of expressiveness that we're looking to get out of image analysis to actually, make it make sense. Let's see if, so speech recognition, another area we've been looking at towards human parity. This is an example of the switchboard test. Let's see if I can make this a little louder. I'm not sure if I can. Let's see. Can you guys hear that? Okay. Yeah. So basically, if you ever listen to calls coming through like a 911 switchboard, you hear it on the news all the time, right? What is this person saying? And so we are working to train models based on first of all, on contextual use cases, but just in general, pull the correct text out. And this is built into even like, for example, this same technology is built into PowerPoint. It's built into Teams. So if we're using Teams right here, I could turn on, close. I could probably do it in Zoom too. I'm not sure how to use Zoom. I could turn on closed captions, and it would actually, start emitting the transcripts of what I was saying. Right. My wife actually uses this as she teaches at WPI. And so every year up until a couple of years ago, she would teach a group of Chinese national students. And they would actually do live transcriptions into their Chinese dialects. So she would be speaking in English. They're trying to learn English, so they want to engage with her in English. But hey, maybe after the fact, or maybe they just missed something, they can be looking at the live transcript in Chinese as well. And that's just happening during class as she's lecturing. So in this case, it was that's how old ours was. That was our answer. We're using the same technology in the UN. So take my wife's case and extend that out to, I don't know how many languages, 45 languages or something at the UN. that people want to listen to transcripts. So we were able to, the Microsoft speech technology is sitting behind the UN live translation service. Speech synthesis, this is another sound one that we probably won't be able to hear. We'll see. Which of those two is synthesized speech? We all have an idea in our head about what synthesized speech sounds like, right? Did either one of them ever just sound like that? So that first one, A, is actually, no, that was not a human utterance at all. That was completely synthesized by something that we call neural translation or neural voice. So we actually take, we can take an actual speaker's text and actually train a machine learning model to speak just like them. And so that's how we did that. Now we have other non-neural voice models. So you can actually take a speech model, and we have different personas that are just kind of built in. You can actually build emotion in. So there's another example that I don't have today, but we have the same words spoken in, say, different languages by different personas. Then you actually set aside a sadness or happiness factor on what they're sounding like. And that's actually going to change the tone and the pace of how that speech is generated. Now, one way that this is used, this is Lena, who's a broadcaster in China. She's visually impaired. The Hongdan, I'm not sure if I'm pronouncing that right, service center is a center for visually impaired people in China. And Lena is a broadcaster, and she's using this technology to put out audiobooks in Chinese to visually impaired people. And so you think about how much time and effort. I can't remember who was talking. I think it was. I can't remember who was talking about. Maybe it was the Splashtop was talking about the kind of the animation, right, and the voiceovers. It's a lot of work. It's a lot of effort to get these things right and to get these things working, and to read off of that script. But what she's done is she's automated that by training her neural voice, and now it's her, right? And now all these people that know Lena are now listening to her read books to them, especially as children. It's a good comfort level for them. So, we talked to those are examples of how people are using some of this technology, some AI models. AI models really hit, when we think about AI in Microsoft and machine learning and predictive analytics, we really think about it in terms of how people use AI every day. How can business users, so kind of like the non-Python developers, actually create machine learning models or use them inside their code? And then how can actual data scientists use our Azure technology to build more custom models? And so if you think about the everyday uses, I already mentioned a couple, right? So PowerPoint transcription or subtitles, in Teams, the transcription. If you go into Office 365 and you store a document in OneDrive, if you hover over that document and it says, hey, this Word document, here's the key points, it gives a little summarization. That's an AI model that everybody has access to be able to use today. And all of these models, whether it's the transcription, translation, the summarization, are things that we're building into these. We're trying to operationalize, give you access to those cognitive services to build into your applications today. And so who's using these cognitive services? We have over 1 million developers today. Actually, these numbers are even a couple years old, I think. 10 million hours of speeches transcribed monthly through Teams. I'm sure that number went up last couple of years. Xbox delivering personalized experiences, billions of alt text in PowerPoint. Actually, here's a great one in PowerPoint for those that have been out of the PowerPoint world for a while. You can actually go into PowerPoint and kind of put some text on there, maybe drop an image and say, show me some design ideas. And it's going to pull in like a library of like, hey, if you, put this text over here and maybe have it fade into the background, put your text over here, it'll kind of come up with a couple ideas to make things pop, can really convey the message you're trying to do, trying to convey. I'm not a designer by any sense of the imagination. So I've always lived, I call it where the UI don't shine, so anything UI I don't do. I'm a back end guy. So I need help with PowerPoint and now it can help me. So empowering people, just a couple examples of how we put this in the hands of people. First of all, just thinking through like, how we see companies evolve in terms of AI. A lot of people start out in like one of two spaces, either centralized AI, which basically says, I've got this team of data scientists over here and they're going to do the data science work. But the problem is it's, number one, it's tough to engage them. Number two, they end up having this huge backlog, right? I've seen cases where like, a marketing team says, I need to generate this very quick demographic analysis, a customer segmentation model based on this cohort. And they say, all right, well, that'll be 3 years. 3 years, right? Because they just have 3 years worth of work, right? And then it's all politics to get that moved up the chain, of course. But marketing teams don't want to hear that, right? They want to jump into kind of more of a potentially a low code, no code development, where they want to maybe bring some people on into their own team. So we end up seeing that it's tough to scale, and they also a lot of times don't have the empowerment, right? So they might have a good idea, but they don't have the funding, right? Because they can't sell the business on it. Decentralized is kind of the other extreme. Everyone has their own data science, people on a team. You get some pockets of innovation, but again, it's difficult to scale that. Where we're seeing success with building AI or infusing kind of a data mentality is really more the cultural change of saying that, hey, we're gonna have some centralized principles and practices for building AI models or building AI into applications. So everyone's kind of doing it in a similar way. But we're going to, kind of empower each team to really, move forward at their own pace. So we talked about, going to jump into, well, I guess the other areas. So we talked about the pre-built models, right? There are some easy ways to generate your own models. Inside of Power BI, Power Apps, and Power Automate, for example. And I can point at a data set and say, hey, I want to predict, maybe it's customer churn, or maybe I want to do a forecasting model. So I want to do sales by month forecasted out for 15 months or something like that based on this data set. I can write inside of Power BI, say, generate a predictive model based on this data set. And it's going to run through we call it auto ML process to train a bunch of models, pick out the one that's the most accurate based on how we decide to measure it. That's kind of part of the setup. And then I can just build those results right into my Power BI dashboards. Same thing with Power Apps. If you're not familiar with Power Apps, it's another low code development tool inside the Microsoft ecosystem. But that same auto ML feature exists. Power Virtual Agent is a bot service, right? So you think about your language understanding, type of models, and then calling out to other cognitive services inside that bot. Again, built right into the Power Platform, where I don't actually have to develop anything to do that. I can just take advantage of models that exist or easy ways to generate models. Now, we have a number of kind of more scenario-specific services, and that's what these the Power Platform services are built on. That bot service I talked about, cognitive search is a search platform. The one I was going to mention was Forms Recognizer. So Forms Recognizer is kind of a combination of OCR and computer vision. And I was working with a customer just a couple weeks ago, and they were looking at validating COVID vaccination cards, right? So I take a picture on my card, I send it in a PDF document, or attach it to my form as an application to work with this company. And what they've done is they've taken using forms recognizer and pull out the appropriate information to make sure that, hey, yeah, that is this person's name, the date of birth looks right, and they do have the two doses and a booster shot that we require to work with us. This is in a healthcare environment. Now, if you've ever seen a COVID vaccination card, they come in, a lot of them look kind of the same on the outset, but some of them have handwritten, some of them are typed, some of them have stickers, some of them have some handwritten, some stickers, right? And so they were able to use this forms recognizer approach to just, hey, it should look about like this, and it's going to pull the relevant information out. And they were able to get, I can't remember it was around the 80 to 85% accuracy, which is a lot better than they had with 0% accuracy to validate these documents. We see this a lot with invoice processing, receipt processing, things like that. Actually, we have some pre-built models around those. Spatial analytics, I talked a little bit about. Spatial analytics is kind of the evolution of there's computer vision, which is like, hey, I'm analyzing an image or a video stream, I'm pulling individual frames out. But with spatial analytics, what I can do is with one camera, and this always required two cameras, but with one camera and a couple of measurements, I can now say, Andy Roberts is 15 feet away from Tim Roberts, right? And that starts opening up. I can draw polygons, for example, onto a surface, opening up some very interesting use cases. Retail environments. How many people are standing in line at a register? How many people are hovered around a kiosk, and how long have they been there? Do I have people crowding in one area of the store and I need to spread them out, right? Those are all things that just with a standard IP camera that you probably have in store today, I can start pulling that information out. We see a lot of this in workplace safety, parking analytics, freight and transportation. So we've actually had there was a good overview of like a overhead camera in a kind of a warehouse parking lot. Where should I move trucks? And can a truck actually make this turn, right? So start adding some intelligence into that to automatically route people to the appropriate spaces. Yep.
IoT devices, for example, Linux devices. These models be pushed down so they operate effectively in a small Linux device.
Yep.
Yep. Is that the intent now?
Yeah, that's a great question. The question was, do I have to run these models in the cloud, or can I push that model into kind of an on-premises or on-site device, right? And so that's, the idea is that we would have, for that type of complex analysis, probably we call an edge gateway. So it's an edge device running usually Linux that is running Docker containers, and we push the model into that device via a Docker container, and we kind of build a workflow for how messages are processed, so how those video frames are processed, and what we do with those results. That's the whole idea of I don't want that decision to be wait until that 25 megabyte image makes it to the cloud, right? And then we talk about so on top of there's pre-built models, right? So in Azure today, without doing a lick of work, I can say send an image to the computer vision service, and it's going to tell me that there's a bicycle and a sign and a tree. But if I want to train this on things that I need to know, so I'm actually working on a example right now with a seafood company, and they're trying to do it's like kind of a proof of concept, looking to detect whether there are bad lobster tails, right? So I've got a tray of 50 lobster tails. Is there such a thing as a bad lobster tail? No. There's 50 lobster tails on a tray, and some of them don't look good. And so it goes on the conveyor belt, and we pull out. We hit that image with the camera, and we say, okay, there's 2 lobster tails that don't look good. Pull those off, right? And so that is what we call a custom vision service. So I can take that image We use something that's called transfer learning, where we have this big convolutional neural network, which is just another term for a big thing that generates the math equation. It's a really big kind of we call network. We replace the bottom, we retrain the bottom layer of that network with our own images, right? So now we reuse this vast amount of work that the industry has done and just adapt it to our specific environment, right? So that works in computer vision, works in speech. So Nuance Healthcare has done this, which is now part of Microsoft, has done this with the healthcare setting. So you might know Nuance from like the Naturally Speaking, Dragon Software. Actually, my uncle actually wrote his master's thesis with Dragon Software. He's a quadriplegic, had no ability to write, but he's able to write his his PhD thesis with Dragon Software. They have something called DAX, which is not, for those that are Power BI people, not anything to do with Power BI, but it is a ambient intelligence transcription service. So if you think about 80% of what a doctor does, a clinician does, is transcribe and look at notes and map those up to billable items that they can then send for billing. And so with DAX, it can either be on the phone or a device that's just in a observation room, for example, or a physical room, and the conversation that I'm having with my doctor is being automatically transcribed. And it's not being automatically transcribed with just the standard thing that we have in Power BI that probably doesn't know, what 20 cc's of D5W means. It knows what 25 cc's of D5W means. It's been trained to understand that context and can pull that out and say that the doctor ordered 25 cc's of D5W, for this patient. Right, and actually put that into the patient's chart, not just as text, but as an order that was performed, or a prescription that was made, or an operation that was, recommended. So really taking specific action around the context. So we're seeing use cases like this in financial services, right? Analyzing analyst calls, for example, and boardroom meetings and things of that nature. And I'm just going to kind of skip through a couple of these guys. Oh, and all of these models, right? So we talked about the computer vision. All of those models that we train with the cognitive services and do the custom analysis to can be deployed using containers wherever your data resides, whether that's in a hospital environment, a manufacturing environment, in a construction site, or in the cloud, or wherever you have, or in a car. Right, wherever you need that to reside, as long as it runs, an environment that can host a Docker container, right? Allstate, for example, is using the custom speech service for a call center analysis. So if you think about, calling in, and we actually have a few call center examples that I've worked on with folks, but build this out so we don't spend too much time on the build. But I'm speaking on the phone as my number one, I can transcribe the speech. I can also look at like voice patterns, right? Do I sound really angry, or do I sound like I'm happy-go-lucky? Is my inflection changing during the course of the call? Is that call center rep kind of bringing me down or ramping me up? Do I need to alert a supervisor? Are we going to lose a customer, right? Make those decisions there at the point of the call, not 3 days later after we've loaded all the data and can analyze it. So we're doing a lot of work in that space. And then as we get down to the bottom layer, it's the machine learning platform, right? So for all of those cases that, there's just not a pre-built model that's going to do it for me. Medical imaging, for example, like we have a lot of computer vision service, a lot of the work we've done in computer vision services. But when you get into high-res medical imaging and you're looking to detect a tumor in a lung, or I was working with a customer that's doing a protein. I can't remember the name of the term for this exactly now, but they're generating proteins to fight diseases. I can't remember exactly the term of this research, but they were looking for dead cells. So they have a slide that was like a cross section, and they were looking for dead cells on this slide. Pretty tough to do. But so the standard computer vision model is not going to work for that. It's not going to work. So what we did is we had them use the machine learning platform. We have some automation that we can put to this process of automatically tagging images and whatnot. But they had to build up their own model to kind of support that use case. We see this, for example, predictive maintenance. We see a lot of times, the number of variables are pretty high, right? So we might not have a good, we have some metrics advisors and some anomaly detections, but if you want to say, hey, is this engine going to fail next week, or do I have 6 months of life left in this aircraft? That we need a little bit more processing. So we see, oil and gas, elevator repair are definitely areas I've worked with predictive modeling, predictive maintenance modeling. And the idea is I'm ingesting that data. Again, I've got that edge device, right, that's collecting data from a number of sensors, sending it into Azure, landing it in a data lake, for example, and then I can build models on it, and then I can make decisions kind of in real time. Little Caesars was actually used Azure for predicting capacity in their restaurants. They have a 3-minute guarantee for a pizza. I didn't know this. We don't have any Little Caesars in Boston. I think there's one in Chelmsford, isn't there? There used to be.
It moved.
It moved. Yeah. So exactly. So you wait more than 3 minutes, you're going to lose customers. You make too many pizzas, you're going to lose money, right? Either way, you lose money. So they want to get a closer demand, right? So they were able to use kind of a forecasting model to start predicting demand using Azure services. This is kind of their inventory, very high level, their inventory management process, right? So just quickly, inside of this ML stack, I mentioned AutoML along with Power BI. We've got the same, that's really driving this Azure ML behind the scenes. So I can do an AutoML type of approach here where I just say, hey, I've got a data set. Here's the column I need to predict, generate a model for me. We have a design surface, so more of a visual designer. So I don't think I have a description of that. I've already talked some of those use cases. We have actually in the background here, you can see the visual designer where I drag and drop, much like you would do with a drag and drop ETL tool, only when I'm dragging and dropping is machine learning components. I have a data set. I need to split that data set to a training and test data set. I'm going to train a machine learning model. I'm going to evaluate the results. I run it. It does that work. I click on the model and I say, okay, now I want to publish this. It's going to put that into behind a web endpoint or generate a Docker container for me that I can deploy to an edge device. So that's all kind of code free. And then the third experience is really more around the notebook experience. So this is where your Python developers get excited. So we finally get to them where you can actually come into a code first experience and really craft the solution that's going to meet those most challenging of needs. And then I guess what I'll end on just 2 more slides. One is on ML ops. This is kind of going back to the very beginning, right? I've trained a model. I've deployed that model into a service that people are using. As I'm using that service, the input data the skew of that data is going to change because I'm changing behavior, right? If I'm doing sales forecasts and I'm saying that Tim's not going to do well this year, you've got to make some changes, and Tim makes those changes, right? Then all of a sudden I see that those changes change what the forecast is going to be, right? So we start thinking about the inputs differently. So we'd have to regenerate that model. I would never say Tim wouldn't do very well in a year, but that's just, there's that visual designer. And then the last thing, again, the responsible AI. We want to make sure that the decisions we're making are responsible, they're good, that we're, and I'm not going to go into the details here, but you'll see it in the slides. We have kind of principles, practices, tools to help you use AI responsibly within your organization as well. With that, any questions?